Hey guys, Lissandro here, and today I'm gonna do another calculus tutorial. So basically, I've been using this software for quite a while to do tutorials on algebra. That's good and all, but I thought I'd use it on calculus and kind of improve on some of the demonstrations that I do on calculus rather than relying on the simple pen pad to write down. Don't get me wrong, it's good and all, but the thing is, it's kind of hard to use at times and really tedious. So, um, if you haven't checked out my algebra or calculus tutorials, I recommend you go check them out and everything. But anyway, let's get started on this. So basically, the deal with this is already got is already got started on instantaneous rate of change, which is some of the basic things they start you off when you start on calculus. And pretty much, I'm sure a lot of you all are already familiar with slope, which is delta y divided by delta x, which pretty much this is your average slope or rate of rate of change. Okay, and that's fine and all. That's fine if you want to find like pretty much like a uniform continuous slope or change. That's fine. But the problem is what happens when you get, for example, in terms of something like, for example, let's say x squared. Only talking about one of the quadrants or anything exponent. Let's say it doesn't necessarily have to be x squared. It could be x cubed or x to the fifth or anything in general. Anything that in regard to exponent. And the question is, what do you do there? And that's when you come up with instantaneous rate of change. And pretty much the deal is that what they give you is a formula like this, which is which pretty much is y prime is equal um, to delta y divided by delta x, which is equal to a formula that they give you that's pretty much it goes like this. Okay, so they give you limit, okay, and then it's delta x, okay, and that of course approaches to 0, okay, and it goes on like this: f of x plus delta x, okay, then minus f of x divided by delta x, okay. And already covered this on the other video now, and pretty much if you look on the diagram I'm showing right here, it's pretty much displaying what the deal is with the relationship between like x and y, okay. But anyway, I already covered that in the other video. Okay, but the thing is that as you progress further along, one of the things they eventually cover is that there's a simpler way to deal with this rather than writing out the whole entire formula. Both they work pretty well, but this is proper also. But the thing is, when you're doing like a job in engineering, also time and efficiency counts and everything. You do calculations and everything, and pretty much you get into this what they call derivatives, and basically, let's say for example, you're trying to find the derivative of, let's say, x squared. Okay, x squared plus, let's say, 2x plus 9. Okay, you're trying to find the derivative of that. Of course, you could always plug it in into the original formula, but there's, like I said, there's a simpler way, and the simpler way is this. The formula is that pretty much this. Your original y is equal to, let's say, c to the power of n, okay, plus x. Okay, so pretty much y, um, your y is equal to c and c to the power n plus x. Okay, and this, you pretty much get this when you apply the derivative, which is your y prime, which is equal to n c, okay, to the power of n minus 1, okay, plus c. Okay, so yeah, this is essentially what you get. But anyway, um, so pretty much from here you what you do is this. This is pretty much essentially how you go about doing the derivatives. So pretty much your c is x in this case. So your n is 2. So 2 times c, 2 times x, you end up with 2x. Okay. Okay, and n minus 1, 2 minus 1 is 1, so it stays pretty much x, the same. Okay, now you go along with 2x. Okay, so in this case, x is 1, x, one sec, pretty much x to the power of 1 minus 1, minus 1, it will equal to 0, and anything to the power of 0 is 1, so pretty much you're left with 2, and pretty much your last option here is pretty much discarded at this point. It's not included, so at this point you're pretty much done. 2x plus 2, and that's the derivative of x squared plus 2x plus 9. So it's a much more simplified way of doing things. Okay, so let's go ahead and try another one. Let's say I throw in, for just out of random, 3 to the power of 4. Okay, to the power of 4 plus let's say 5x um, let's say to the power of 3, okay, plus 2x plus 1. Okay, so basically, you already have 3x here, and as you remember the formula earlier, um, let me write it down again. C to the power of n, okay, plus x, and of course this is your y, okay. Pretty much that you go about doing this. Y prime, oops, y prime equals n times c to the power of n minus 1. And essentially that's it in reality. That's all you get, because remember the x is discarded, the integers discarded. Okay, so anyway, let's start. So 3 times 4, that's essentially 12x. Okay, 4 minus 1, that's 3, so you have to the power of 3. Okay, plus 5 times 3, that's 15. Okay, x. 3 minus 1, that's that would be to the power of 2. Okay, plus 2 times 1, that's 2, and 1 minus 1, that's 0, so you're pretty much left with 2. Okay, and that's pretty much it. Go ahead, keep practicing this. You eventually get better field of this. Pretty much a better understanding as you practice and go along. You'll pretty much get the hang of it and all. Later on, I'll explain. I'll go deeper into derivatives and what chain rule is, because this is not the only way you get derivatives. It gets a little bit more complicated when you apply division to the equation. I'll pretty much show you how y'all deal with it. But anyway, guys, thank you guys for watching. Please like and subscribe. And pledge to my Patreon, of course. I can't stress that enough. And I'll catch you guys later. Bye.